In this video, we're going to look at sketching contours and sections. So we have a surface equation here, z is equal to 3x plus y, and we need to sketch the contours. Okay, so that is when z is constant. Now we haven't been given a specific value for z, so in this instance, we're just going to have to start by setting z equal to c, where c is some constant. Okay, so I'm going to write c is equal to 3x plus y. Okay, and the idea is c is a constant. So then we're going to have a go at sketching our contours. So first thing we need to think about is what we're going to label our axes. Remember, we're only going to have two axes here because we set z equal to a constant. And our variables left over are x and y, so it's going to be x and y. And we always put the letter that comes first alphabetically on the horizontal axis, although you're used to the xy scenario. Then what type of graph is this going to be? Well, we got our x term where x is to the power of 1. We got a y term where y is to the power of 1. We've got a constant. Well, this is a linear graph. So I'm going to rearrange it into the form where y is the subject. So it would be y is equal to, and we'd have c subtract 3x. Okay, like that. So if I was having a go at drawing this, I'm not really sure what c is currently. The idea is you're going to just pick a few values for c. You're going to pick 3 or 4 and draw them onto the graph because we haven't been given a specific value for z. So let's just consider when c is equal to 0. Okay, then we would get y equals negative 3x. Okay, so drawing that, it's going to go through the origin and we're going to have a negative gradient. So my line is going to look a bit like this. Okay, so that would be when c is equal to 0. I'm just going to indicate a 0 there. Now let's change c. Okay, so let's consider when c is equal to 1, maybe when c is equal to negative 1. And let's just think about what that's going to do. Well, this constant, if I keep changing it, that's going to act as a translation. Okay, if this was initially 0 and we add 1 to it, okay, we're going to shift the graph up 1. So my next contour would look a bit like this. It would be parallel, the same gradient. Okay, and we'd say that is when c is equal to 1. And I'm just going to indicate a 1 there. Then if we went for negative 1 instead, well, that would shift the first line I drew down 1. Okay, so then it would look a bit like this. Once again, parallel. We're not editing the gradient here. And then that gets me another contour. And I think 3 should do, but you could do a couple more if you want, as it's not particularly tricky once you've already got sort of 1 on your page. So let's move on to part B. And part B says sketch the section for x equals negative 1. So this time, we've been given a specific value to substitute in. So let's sub it in and consider when x is equal to negative 1. So we would get z is equal to 3 lots of negative 1 plus y. And then if we rearrange and simplify further, we get z is equal to negative 3 plus y. Okay, so that would be the equation that I'm going to draw. Okay, so I'm only going to draw one graph this time. Now let's just think about which axis. Our variables are y and z. So when I draw out my axes, one is going to be labeled y, the other z. So y comes first alphabetically. So that goes on the horizontal axis. And z would go on my vertical axis. Now once again, this is a linear graph. Okay, because the z and the y are to the power of 1. And the negative 3, well, that essentially represents your, what I'd call now a z-intercept, but it's the intercept on the vertical axis. So I'm going to mark negative 3. And then if we look in front of the y, we have positive 1y, so the gradient is going to be 1. So positive gradient, and then we can have a go at drawing our linear graph like this. Now, the other thing I'm going to find in this scenario is, what is this point here? So our intercept on our horizontal axis. So that is what we'd call our y-intercept. Now that is going to be when z is equal to 0. So if we sub in 0 for z, we get negative 3 plus y. And rearrange, we get y is equal to 3. Okay, so that would be a positive 3 like that. Let's look at a different surface equation. So let f of xy equals to 3x squared take 2y, and it says the surface S has the equation z equals f of xy. So I could rewrite this as z is equal to 3x squared take 2y. Then it says find the equation of the section where we got z equals to f of x and then 2. So that means the y has been set equal to 2. Okay, so we've got the section and we've got a specific value for y, which we're going to sub in. So we're going to get z is equal to, the 3x squared stays the same, and then we get negative 2 multiplied by y, which is positive 2. So if we simplify that, we get z is equal to 3x squared take away 4. So let's have a go at sketching this. So I'm going to draw my axes and just think about what we're going to label them. So our variables are x and z. So x goes horizontally and then z goes vertically. Now this time we've got a quadratic. Now what I know about this quadratic is the y-intercept, sorry, not the y-intercept actually, it would be the z-intercept is negative 4. So I'm going to mark a negative 4 down here. Now what I also know about this quadratic is because there's no x term, okay, because it skips from the x squared term to the constant term, it's going to be symmetrical about the z-axis. So I can draw it in straight away and it's going to look a bit like that. Okay, with the turning point being negative 4, because essentially this isn't completed the square form. We have our squared term, we have our squared term here, and then our constant negative 4. So our minimum value is going to be negative 4. However, I would like to find my x-intercepts. So that is when z is equal to 0. And then we can solve this one by rearranging. So we get 3x squared is equal to positive 4. X squared is equal to 4 over 3. And if we square root, we get x is equal to the square root of 4 over 3. But don't forget your plus or minus. So then we can label our intercepts on. So we'd have positive root 4 over 3 and a negative root 4 over 3 like that. Again, that would be a full sketch of our section. Now let's have a look at part B. So it says find the gradient of this section when x equals negative 2. When it says this section, it's referring to the section we are working on in part A. So I can bring the equation of the section down. So we got z is equal to 3x squared take 4. Now what you're not going to do is just substitute negative 2 in for x. That's not going to give us the correct answer because we need the gradient when x equals negative 2. So remember, to find gradient, we need our gradient function, so we need to differentiate. So it'd be differentiating z with respect to x, because x is our variable on this side. So if I differentiate 3x squared, I would get 6x. And if I differentiate negative 4, you'd get 0. So we've got our derivative, and we need to consider specifically when x is negative 2. So now I am going to substitute negative 2 in. Okay, but we're going to sub it into our derivative, dz by dx. So that's going to be equal to 6 multiplied by negative 2. So the gradient comes out as negative 12.